Hello everyone, today we'll be looking at changes of state as well as how to do temperature change graph. So if you look over here, we have the different changes of state. So we can see solid, liquid and gas, right? So let's do the ones that we have learned many times. So from solid to liquid, we have melting. And then from liquid to gas, we have boiling. Right? When we go back from gas to liquid, we have condensation. And then from liquid back to solid, we have freezing. So these are the more common ones that we are aware of. So now when we go from solid to gas, so like for example, like dry ice, which is solid carbon dioxide, it would sublimation to form gaseous carbon dioxide. So sublimation of dry ice, that's one example. And then from gaseous state, you can go back directly to solid state, and that would be called a vapor deposition. So both sublimation and vapor deposition is not very important, but I think it's good for you to know. But what we must know is these two things over here. So a pure substance will always have a fixed melting and boiling point. That means water will always boil at 100 degrees Celsius. It will not change. It is always 100 degrees Celsius, right? And it'll always freeze at 0 degrees Celsius. So a range of melting and boiling points is like seawater would maybe boil between 101 to 110, right? There's no fixed temperature like pure water, right? And the next thing we need to know is that when melting and boiling, the temperature will always remain unchanged until everything boils finish. So let's see how it looks like in a graph. So let's look at heating graph of ice to steam, right? So ice will start maybe at around, let's start at very cold temperature. So 0 degrees. So we will expect, right, that when I heat something up, the temperature will just keep rising and rising and rising and rising and rising, right? Because I heat it up, the temperature will just keep going up. However, that's actually not the case. So what happens is that as I heat my ice, it will continue rising, 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 rising until it reaches the melting point of ice, which is 0 degrees Celsius. And then once it's at 0 degrees Celsius, it will start melting. So it will remain straight here until all the ice melt, and then it will slowly keep rising until I hit the next point, which is 100 degrees Celsius. So over here, it will remain constant as it boils because it's the boiling point of water. And then after once it finishes, it will continue going back all the way up. So what we can see is that there are a few sections over here. So let me use my highlighter to show you. So I can divide it like this, right? And there is section A, section B, section C, section D, and section E. So at section A, we only have solid water, right? And once we heat up the solid water, is heating up, then we have here the solid will slowly turn into liquid. So at section B, I have a mix of solid as well as liquid. And this process over here, we are melting. Okay, we are melting it over here. So only after all the solid keeps decreasing and then the liquid keeps increasing until we reach the end of section B, where only liquid is left. So over here, only liquid is left. So the temperature keeps rising until you reach the next point where the liquid will start changing to gas. And this is a process of boiling. So the liquids will keep decreasing as it changes to gas, and the gas keeps increasing until the point where there's no more liquid, right? Then at this point, there is only gas. Okay, so there are two important temperatures that this occur. So let me highlight it for you in red. So one is at 0 and one is at 100. So 100 will be called the boiling point, right? Take note that it's not always 100, but it is the point, right, where it is liquid and gas, right? That point over there, that's 100. And the one at the bottom, this is the melting point. So the melting point is where it exists as solid and liquid at the same time, right? So this is the heating curve. So let's look at it in the opposite direction, the cooling curve. So we will again expect, as we cool something down, we will expect it to just keep decreasing and decreasing and decreasing like a straight line like this. However, that doesn't happen. So what happens is that it will decrease. Let me use another color. It will decrease until you reach the boiling point, right, which is 100. And then it will start condensing. It will go down all the way until it reaches the next point, which is the melting point. Oh no, what happened here? All right, let me erase that. So it will continue going straight, and then after that go down, then go straight, and then go down. So this point is 0, and what we know is that at this point here is gas, here is gas plus liquid, here is liquid, here is liquid plus solid, and here is solid, right? Similar to the one on top. In red, this one is known as the boiling point, and over here this is known as the melting or freezing point. All right, so that's how you represent your state changes in the form of a temperature graph. Right, so I hope that has been helpful for you. I'll see you in the next video.